with methods to avoid the interference. First one is to select the correct minimum number of teeth on pinion and gear using analytical equations, which we will derive soon. Second method is to remove the interfering portion of the non-tangent flank using the process of undercutting. Okay. Number third one is to modify the tooth profiles. We know that tooth profile above the base circle is involute and that below the base circle is non-involute. Okay. If you cut the teeth below the base circle, that much portion of the teeth will be non-involute one. Okay. So this portion below the base circle is non-involute. And for mating teeth, if we consider the portion below the pitch circle to be involute, now this portion, the face of the teeth number 2, let us call this as teeth number 2. Okay. Let us suppose this is teeth number 2. Now this face of teeth 2 will mesh with the flank of teeth 1, and the portion of the flank of teeth 1 below the base circle is non-involute. Okay. What we can do here, two mating non-involute profiles are converted into the cycloidal one so that they can mesh with each other without producing any kind of interference. So this is how we can modify the tooth profiles of mating teeth. Okay, so here we have written last time that portion of flank of pinion tooth, that means this portion below the base circle, and the portion of face of the gear tooth that engages with it, that means this portion of the engaging tooth, are made cycloidal. Okay, and in case of cycloidal profiles there is no problem of interference. Okay. Now number 4, write down number 4, modified addendum of pinion and wheel. So please write down this. We will continue the methods to avoid the interference. Number 4 is modified addendum of pinion and wheel. Now no need to draw this diagram. We have already drawn it in method number 3. Okay. So this is the root circle, which is shown in blue color, the circle passing through the roots of the teeth, and this is the addendum circle, which is passing through the top of the tooth. Okay. And the circle shown in red color is pitch circle. Okay. Now what is this AW? This is addendum. Radial height of the tooth above the pitch circle is called as addendum, or the distance between pitch circle and addendum circle measured radially is called as addendum. So I have shown here AW, addendum of gear wheel. Okay. This is addendum of gear wheel. Now what is DW? Radial depth of the tooth below the pitch circle. Okay. That means radial distance from pitch circle to the root circle or dedendum circle is called as dedendum. So we have shown AW as the addendum of gear 2 or addendum of wheel, and DW as the dedendum of wheel. Now if just listen. Now if this addendum circle of gear intersects the pressure line beyond the interference point. If addendum circle of gear, that means this circle, intersects the pressure line beyond the interference points, what will happen? Point of contact will go inside the base circle of pinion and interference will occur. Okay. So what we can do? We can reduce this wheel addendum AW. Okay. So that it will decrease the addendum circle radius of gear. Okay. So now it will not pass through the interference point, or it will not move the point of contact beyond the interference point. Okay. So this can be avoided by reducing the addendum of wheel, the value of AW, so that it reduces the addendum circle radius. But because of this, the working depth of tooth will get disturbed. The working depth of gear will get disturbed. So to compensate the working depth, change in the working depth, if you reduce the addendum of the gear wheel, we must increase the dedendum of gear wheel, so that the total working depth is preserved. Okay, got this? What we can do, we'll repeat this. What we can do, if the addendum circle of gear cuts the pressure line beyond the interference point, it will shift the point of contact C inside the base circle of pinion. So we need to decrease the addendum circle radius. And one of the ways to decrease the addendum circle radius, that is radius of this circle, is to reduce the value of addendum. Okay. So we can reduce the value of addendum, which will decrease the addendum circle radius. Then this will change the working depth. So this is not desirable. Now to preserve the working depth, we have to increase the dedendum of the wheel. And this can be increased by reducing the root circle radius. Okay. To preserve the working depth. Now this is for gear. Now gear and pinion both will work in the same working depth. Okay. So we have to modify the addendum of pinion also. Okay. So if we reduce the addendum of gear, we have to increase the addendum of pinion, because face of the pinion is going to mesh with flank of this gear, or face of the gear, this portion will mesh with flank of the pinion. Okay. So if we reduce the addendum of gear, we have to increase the addendum of pinion, and hence we are reducing the dedendum of gear, we have to decrease the dedendum of pinion in order to preserve the total working depth. Okay. So this is how we can avoid the interference by modifying addendum of pinion and wheel. This is done only if the addendum circle of pinion or gear is intersecting the pressure line beyond the interference points. Okay. And number 5, increased center distance. Okay, this is number 5, increased center distance. So write down this. Number 5 is increased center distance. Now what actually this means? What we have seen, we have two interference points E and F on the base circle of pinion and wheel, and we have studied this in studied that in case of involute gears, path of contact CD. Okay, this path of contact CD must always lie in between these interference points, correct, in order to avoid the interference. If this is not happening, what we can do, we can increase the pressure angle so that the path of contact lies in between the interference points. Okay. One of the ways of reducing the path of contact, or making sure that path of contact CD lies in between interference points E and F, one of the ways is to increase the pressure angle. And pressure angle can be increased by increasing the center distance between two meshing gears. Okay, what is, you might be remembering what is pressure angle. Okay, so these are the two pitch circles of meeting gears which are in contact with each other at pitch point. If I draw the common tangent to these two pitch circles at the pitch point, And I will now draw the base circles. Okay. This is base circle 1, this is base circle 2, and we have this pressure line passing through the pitch point, and this pressure line is common tangent to both the pitch circles. And we have seen that angle between these two lines, common tangent to two pitch circles and common tangent to two base circles, is the pressure angle, correct? Now, one of the ways of increasing the pressure angle is to increase the center distance. We can increase the center distance between the gears so that this line shifts. If we shift the center A in upward direction, it will shift this pressure line upwards and it will increase the angle phi. Okay. So we can do this and make sure that path of contact lies between the interference points. And this is possible because we have seen that change in center distance does not affect velocity ratio in case of involute gears. We have seen this while studying gear tooth terminology. Okay. So just remember that increasing the center distance will change the pressure angle, and this will make sure that path of contact always lies in between the interference points. Okay. And this is possible because change in center distance doesn't affect the velocity ratio in case of involute gears. Okay. We have seen this. Revise this, okay? You might be remembering this diagram. We have drawn this number of times. Now what is AE? AE is the base circle radius of gear 1. AE is the base circle radius of gear 1. This AE is equals to AP cos of phi. Okay? AP cos of phi. From which triangle? From right angle triangle AEP. What we get? AE, this AE is cos of phi times the AP. Okay? It's very simple from this right angle triangle. Similarly, from right angle triangle BFP, we get BF equals to BP cos of phi. We know this, okay? Base circle radius is always cos of phi times the pitch circle radius. We have proved this. The next, cos of phi equals to, from above equation, AE upon AP, and from this equation, cos of phi is BF upon BP. Okay? No need to write down, we have written this already. Cos of phi equals to BF upon BP. Now you can equate these two equations because both of them stands for cos of phi. Okay? You can equate these two equations. So what we get? AE upon AP is equals to, this is equals to BF upon BP. Now we can rearrange it. BP इकडे गेला, okay, and AE इकडे आला. So what we get? BP upon AP is equals to BF upon AE. Now we know that velocity ratio is equals to BP upon AP. Okay, velocity ratio is equals to BP upon AP because we have seen that pitch point divides the center line in the inverse ratio of velocity of gears. So if I consider this as gear 1 and this as gear 2 and write the velocity equation, omega 1 upon omega 2 is must be equals to distance BP, okay, upon distance AP. This is the property of pitch point in case of involute gears. Pitch point divides the center line in the inverse ratio of angular velocities of two machine gears. So that's why velocity ratio is BP upon AP. But BP upon AP is equals to BF upon AE. So let us substitute this. So what we get? Velocity ratio is BP upon AP, which is also equals to BF upon AE. Now what is BF? BF is the base circle radius of gear 2, And what is AE? It is the base circle radius of gear 1. So radius of base circle of gear 1 and gear 2 will not change. They will remain constant. Even if we change the center distance between these two gears within limits, it will not change the values of base circle diameters or base circle radius, because we are simply shifting the gears away from each other, correct? If we try to change the center distance, let us suppose that we shift center of gear B towards left in order to increase the center distance AB. Whether it will change the base circle radius? No. So change in center distance doesn't affect this ratio. That means velocity ratio is unaffected by change in center distance in case of involute gears. So we can change the center distance safely, in order to increase the pressure angle and make sure that path of contact always lies in between the interference points. Okay, got it? So this is important question. If I have to remember this, we have to remember this. A theory question of 4 marks may be asked on methods to avoid the interference. Okay. Now next, what we have seen up till now is definition of gear drive, classification of gears. Gear drive is a positive drive. We have classified the gears based on the position of shaft axis. We use spur gears and helical gears to connect parallel axis shafts. We use bevel gears to connect intersecting axis shafts. And we use crossed helical gears to connect non-parallel and non-intersecting axis shafts. Then we have gone through the gear to terminology. Okay. Then we have studied the law of gearing, which ensures that velocity ratio remains constant, or which states the condition for two meeting gears so that the velocity ratio is constant. Then we have studied two conjugate tooth profiles, cycloidal and involute one. Then we have seen the involute gear tooth action. We have derived the equations for path of contact, arc of contact, and contact ratio. And we have seen what is the interference and undercutting in case of involute gears. And finally, we have studied the methods to avoid the interference. Okay. We have studied methods to avoid the interference. Now, let us continue. The number one, first, what is the first method to avoid the interference? To select the minimum number of teeth on gear and pinion. Okay, we can avoid the interference by selecting the minimum number of teeth on gear and pinion. This was our first method. Now let us find out the analytical equations to find out the minimum number of teeth on gear and pinions so that interference is avoided. So all of you will draw this diagram with me. Draw the pitch circles of two meeting gears. Draw the pitch circles for two mating gears. Mark centers A and B. Draw the center line. Mark centers A and B and draw the center line AB. Then show the pitch point P, which is the point of contact of two pitch circles, and it must lie on the center line AB. Next we draw the base circles for gear 1, which is concentric to pitch circle 1, and base circle for gear 2, which is concentric to pitch circle 2. So draw these two base circles. Chetan,
Yes, sir.
are you drawing?
Yes, sir.
Okay, very good. Now नंतर काय करतो आपण? What we do? We draw the line of action, which is tangent to both these base circles. So produce this line EF. No need to tell this now. EF always passes through pitch point P. So draw the common tangent to both the base circles. Line EF passing through pitch point P. Okay, passing through pitch point P. Now this pressure line or line of action is perpendicular to radius of rotation AE and radius of rotation BF of the base circles. Okay, so draw these two lines AE and line BF. These are perpendicular to pressure line EF. Okay, at these points of tangencies. Next, show the pressure angle at the center of gears. Pressure angle phi at the center A and center B. Done. Now we will show the beginning of engagement. Where does engagement starts? Engagement begins where the addendum circle of driven gear intersects the pressure line. So now we will draw the addendum circle of driven gear. This addendum circle intersects the pressure line at point C, where a pair of teeth comes in contact with each other. So mark the point C as the point of intersection of addendum circle of gear 2 and the pressure line EF. Next, we will mark the point of end of engagement, that is point D. A pair of teeth will seize the contact where addendum circle of driving gear intersects the pressure line. So let us draw the addendum circle of driving gear. Draw the addendum circle of driving gear and mark the point D as the point of intersection of addendum circle of driving gear with the pressure line EF. So this is my point D. Okay, this is my point D. This is my point D. Gajanan Guru, झाली का diagram? Okay, so we will proceed. Now CD, आता काय करायचं? Just listen. CD is the path of contact, correct? CD is the path of contact. CD is the path of contact. RA is the addendum circle radius of gear 1, correct? RA, you can show this in the diagram. RA is the addendum circle radius of gear 1. Now what? And R is the pitch circle radius of gear 1. You can show these two dimensions. Small RA, addendum circle radius of gear 1, and small r as pitch circle radius of gear 1. Now we have seen, what we have seen? In order to avoid the interference, we have seen that in order to avoid the interference, addendum circle of gear 1 must intersect the pressure line EF before point F. So what we have, we can say that maximum value of addendum circle radius is distance AF, correct? So join point A to F. Draw one dotted line joining point A and F, and write down this RA max. Maximum value of addendum circle radius of gear pinion is equals to distance AF. So that interference is avoided. Correct. So RA max is AF. Now we will identify maximum addendum of pinion to avoid the interference. Addendum means what? Addendum म्हणजे काय? If this is my teeth, this is the pitch circle. Addendum म्हणजे काय? Radial distance between addendum circle and pitch circle is the addendum. Okay. Now if addendum circle is passing through point F at its maximum value, RA max, what will happen? Addendum circle will pass through F. Now it cannot go beyond F. It will cause the interference. So what we have said that RA max is equals to AF. म्हणजे addendum circle radius of pinion is याची maximum value किती आहे? It is equals to distance AF. मग या लाईनवरच आपल्याला मॅक्सिमम addendum मिळेल. So show the point H on the pitch circle of pinion. On this line AF, mark point H on the pitch circle of gear 1. Okay? इथं असेल तो. On line AF, mark point H on the pitch circle of pinion. Now what is distance HF? If AF is maximum value of addendum circle radius, HF will be the maximum value of addendum of pinion. Correct? So write down this maximum addendum of pinion to avoid the interference is HF. Maximum value of addendum of pinion to avoid the interference is HF. Now similarly show the pitch circle radius of gear wheel as capital R, addendum circle radius of gear wheel as capital RA, now from this for gear, write down this for gear what we have RA max is equals to distance BE, correct? Maximum value of addendum circle radius in order to avoid the interference is distance BE. So this distance BE is RA max. Okay. So RA max equals to BE. Now we will mark the maximum addendum of gear to avoid the interference. So if BE is the maximum radius of addendum circle of gear, the radial distance of the addendum circle from the pitch circle is the addendum. So mark point G. Mark point G on pitch circle of gear on line BE, which is shown in yellow color here. GE is the maximum addendum of gear to avoid the interference. So write down this maximum addendum of gear to avoid the interference is distance GE. Okay. Now what we have seen, we will make use of this only. Okay, maximum addendum of gear to avoid the interference is GE, distance GE. Okay. Now distance GE is equals to BE minus BG. Distance GE is BE minus BG. Correct? BE minus BG is our GE. So write down GE is equals to BE minus BG. Written. Now we will find out the values of BE and BG to solve this equation, to find out the maximum value of addendum of gear to avoid the interference. We will find out the value of BE and then BG. So let us go. What is BE? Look at the triangle BFE. Triangle BFE is a right angle triangle at F. So using Pythagoras theorem, what we have? Square of hypotenuse, that is BE square, is equals to BF square plus EF square. Very simple. So write down from triangle BFE, B is equals to under root of BF square plus EF square. Write down this. BE is equals to under root of BF square plus EF square. It's very simple. From triangle BFE, which is right angle triangle at F, using the Pythagoras theorem. Now next, what is EF? You can write EF as EP plus PF. Look at the pressure line. EF can be written as EP plus PF. So substitute EP plus PF for EF. So in this equation, substitute EP plus PF for EF. Okay, so BE is equals to under root of BF square plus EP plus PF square. Now, what is BF? What is BF? Look at the base circle radius of gear, which is equals to cos of phi times the pitch circle radius. Very good. So write down R cos of phi for BF. And what is EP? कोणी सांगू शकता what is EP? From triangle EPA. From this right angle triangle EPA, which is right angle at E, R sin of phi. Because AP is R and this angle is phi at A, so you can write R sin of phi EP. And similarly, PF from triangle BPF, which is right angle at F, we can write R sin of phi for PF, capital R sin of phi. So substitute these values. So BE is equals to under root of R square cos square phi plus in the bracket R sin of phi plus capital R sin of phi whole bracket square. Very simple geometrical relations. So here we are. We have equation 1 with us. GE is equals to BE minus BG. And just now we have determined BE, which is equals to this much. Now further, if we simplify this equation for BE, which we will not do right now, okay? I will share the notes for this. You can study the notes and look how this equation is simplified. It's very simple, okay? We will not waste our time. So after simplifying this, directly write down the equation for BE. BE is equals to this equation number 2. Write down this equation number 2. Okay, so this is our equation number 2, this is equation number 1. We have determined BE. Now what is BG? Go back to the diagram and tell me what is BG. BG काय आहे सांगा. What is BG? It is pitch circle radius of gear, capital R, correct? BG is the pitch circle radius of gear, capital R. So we have equation number 3. BG is equals to capital R. Now what should be the next step? We will substitute equation number 2 and equation number 3 in equation number 1 so that we get the value of GE. So let us do that. Substitute BE and BG in equation number 1. Okay. So what we will get? This equation GE equals to R under root of 1 plus R upon R minus 1. This is our equation number 4. Name this equation as equation number 4. GE is equals to capital R bracket in bracket under root of 1 plus R upon R, again one more bracket, R upon R plus 2 bracket close, sin square phi, and this minus 1 is not inside this radical sign. Okay, so after substituting equation number 3 and 2 in 1, we get equation number 4, which will give the value of GE. What is GE? This GE is maximum addendum of gear to avoid the interference. Okay, GE काय आहे? Maximum addendum of gear to avoid the interference. मग instead of GE, what we will write? AW max. So rewrite this equation. Rewrite this equation by writing AW max instead of for GE. म्हणजे आपण GE लाच म्हटलेलं आहे. Maximum addendum of wheel AW max to avoid the interference. Okay. Now this is the equation with you before you start designing the gear wheel. So you have to follow this equation. While deciding the addendum of your gear wheel, you must select the value of addendum of gear wheel such that your selected addendum value AW must be always less than or equals to its maximum value so that interference can be avoided. So write down, let AW be the adopted addendum for wheel which you are going to select for your gear. Now what I said, this selected value of addendum of wheel must be less than, before that, let me show you how addendum is expressed. So you need to write down this AW equals to capital AW times the module. Addendum is always expressed as addendum coefficient times the module. For all the gears, addendum is always expressed as addendum coefficient times the module. This capital AW is called as addendum coefficient for wheel. Okay. Now we have two equations. Equation number 5, which is the maximum value of wheel addendum, and AW is the selected value of addendum for our gear, which is equals to addendum coefficient AW times the module. And what I have said, to avoid the interference, selected value must be less than or equals to its maximum value. So write this, AW must be always less than or equals to its maximum value in order to avoid the interference. So let us substitute here AW, which is equals to AWM, must be less than or equals to AW max. So write this equation, equation number 6. AW, which is equals to AWM, must be less than or equals to AW max. So now we'll make some changes in this equation. We know that module equals to pitch circle diameter on divided by number of teeth. And module for the mating gears is always same because circular pitch is same. Correct. Circular pitch is pi times the module. So if circular pitch of two mating gears is to be same, module must also be same for two mating gears. So I have written M equals to capital D by capital T. This is for gear, wheel. This is also equals to small d by small t. This is for pinion. So now what we have, D is the pitch circle diameter, which is equals to 2 times the pitch circle radius. So write down this, M equals to 2r upon t is equals to 2r upon t. Now from this, we get capital R equals to mt by 2. Capital R equals to mt by 2. Na? So what we get, M equals to 2r upon t. So what will be R? R will be equals to mt by 2. So write down this, capital R equals to mt by 2, small r equals to m small t by 2. So we have these two equations now. So let us substitute the values of R, small r and capital R, in the equation number 6. So you will directly write down this equation. असं म्हणा तिथं, by replacing small r and capital R by mt by 2, we get this equation. T is greater than or equals to. It's a simplification. You can refer the notes for the simplification. It's very simple. We have just substituted these values for capital R and small r in equation number 6 to obtain this equation. So write this, T, capital T is greater than or equals to this much. Okay. Written greater than or equals to म्हणजे काय? Number of teeth on gear must be always greater than or equals to, right hand side. Number of teeth on gear must be always greater than or equals to this much value. म्हणजेच काय, this is the minimum number of teeth in order to avoid the interference. So rewrite this equation, T minimum equals to, बरोबर, number of teeth त्याच्यापेक्षा जास्त नाही पाहिजे, म्हणजे ते काय झाले, minimum number of teeth should be this much. So write down T minimum equals to this much and name this as equation number 7. Okay. Now, what we know, we'll further simplify this equation. Last step, we know that gear ratio equals to capital T by small t. Gear ratio is number of teeth on gear wheel divided by number of teeth on pinion. आणि इथं काय आहे, small t by capital T. इथं काय मग 1 upon G. So final equation for minimum number of teeth on gear is in terms of gear ratio G. So write down equation number 8. T upon T is the inverse of gear ratio. So we have included the term of gear ratio in the final equation. So this equation will help you to determine the minimum number of teeth on gear to avoid the interference with pinion. Okay. Now similarly, this is our equation number 8, which will give the minimum number of teeth on gear wheel. Now just write down. Similarly, we can find out the equation for minimum number of teeth on pinion to avoid the interference with gear. Okay. And write down this equation number 9. Small t minimum equals to, इथं चेंज काय झालंय बघा, numerator, there is change only in the numerator, and that change is we have replaced the addendum coefficient of wheel by pinion, and in the denominator gear ratio चा inverse होता तो निघून गेला. Very easy to remember. Okay. AP is the addendum coefficient of pinion, and small ap is adopted addendum for pinion, which is again addendum coefficient times the module. Okay.